Okay, everybody, I am going to do my very best to teach you the alternating series test without being here. It's a pretty straightforward test. The first thing you ask yourself is, does it alternate? And so let's take a look at the series n equals 1 to infinity of negative 1 to the n over, let's look at n squared. Okay, does it alternate? Well, see this negative 1 to the n when n is odd, we have a negative term. When n is even, we have a positive term. So yes, it indeed alternates. So I want you to say that. I want you to acknowledge that yes, there's something about this that alternates. Then we're just going to look at the non-alternating piece of this. The second thing we're going to do is we're going to take a limit as n goes to infinity. Ignore the negative 1 to the n. We're just going to strip that off and look at 1 over n squared. Does that nth term go to 0? Whereas before, that wasn't enough to make it converge. Now, if it alternates and goes to 0, we've got something to work with. And then all we're looking at is seeing that is the a sub n plus 1 term less than the a sub n term. In other words, does this decrease? And basically they don't make us take a derivative of all of these to confirm that. We just take a look at 1 over n plus 1 squared. That would be the n plus first term, is putting n plus 1 in for n. N is that less than 1 over n squared, and 99 times out of 100 you're going to be able to say yes, that when you make that bottom bigger, you make the whole thing smaller. And so if you answered yes to all three of these questions, then the series converges by the alternating series test. Just because something alternates, convergent series, convergent test. Boy, that doesn't make any sense. Convergent series converges. Let's try that all over again. I probably should edit this. I'm going to get on a plane in a few minutes. Series converges by alternating series test. There we go. That's much better. So, still, if you show me n equals 1 to infinity of negative 2/3 to the n, I am not going to go to all the trouble up above. I'm going to go, hey, that's geometric. It's an alternating geometric, but I'm just going to say that r equals negative 2/3, and the absolute value of r is less than 1, therefore converges by the geometric series test. So just because something alternates doesn't mean, you're just going to throw away things that that I've already taught you that have worked before. So it's a pretty straightforward test. We're going to find that we have an awful lot of series out there that do alternate, so you're going to find that you use this quite a bit. Now, there is a second component to this, and it's whether it's conditionally or absolutely convergent. In the problem that I just did up above, if you, again, strip away the alternating series part, and we look at, so after we've proven convergence, now we're going to just look at the series without the condition of alternating. We're just going to look at that. And this is a convergent p-series, correct? So we can say that it's great that it alternates, but it doesn't need to alternate. It doesn't need that condition. Therefore, it converges absolutely. So it's absolute convergence. So you're going to have one section of homework that just asks you to use the alternating series test to prove convergence or divergence. Then you're going to have some that ask you to prove convergence, whether it's absolute or conditional, or it could even be divergent. So you want to look at that as well. So let me show you what one of these looks like. If you have, let's say n equals 1 to infinity. I love this. Cosine of n pi. And let's put that over the cube root of n squared. So when you put in integers, 1 pi is -1, 2 pi is +1, 3 pi is -1. So it's such a creative, cute little way to show alternating. The -1 to the n is kind of boring. So yes, it alternates. Does the limit as n goes to infinity of 1 over n to the 2/3 go to 0? Why, yes, it does. And is 1 over n plus 1 to the 2/3 less than 1 over n to the 2/3? That's true as well, because the bottom is bigger on the left than it is on the right, so the whole quotient is smaller. Now, we've proven that it does converge by the alternating series test. However, we want to go one step further, so we're going to strip away the convergent part, that condition, and we're going to look at 1 over n to the 2/3. Well, that's a p-series just like the one was up above, and it is a divergent p-series because 2/3 is less than or equal to 1. So this one converges conditionally, and that condition is that it alternates. If it didn't alternate, it would diverge, but because it has that extra condition of alternating, it converges. I know this is only a couple of examples, but I got to go. I will see you all either Monday or Tuesday, and good luck on your quiz. And know that if there's any problems, please don't stress out another teacher. Text me or email me. I'll have my phone with me, and I will try to calm you down. Everything's good. I will see you when I get back.